Okay, so this is my version of the Tesla energy receiver. As you can see, we got these ceiling tiles that have these metal trussets. So what I did was I went and soldered a bunch. Shut up, you time. So I went and soldered a bunch of the ends together, and then I hooked up this wire here. And basically, we'll just follow the wire. Here, and this is the wire that connects to those tiles, so that's my radiant energy receiver. Okay, this is my Tesla energy, or Tesla's radiant energy receiver. I've showed you this is my antenna. This is my ground. Just to measure the current, I turn my meter on here. I turn it to alternating current, and I'm picking up 55.4 volts of alternating current, fluctuating between the ground and my aerial. Okay, so I believe that's where the energy is coming from in that aspect. So if I want to use this current, what I'm going to do here is I'm going to really simply way to make this alternating current usable, because right now if I switch it over to DC, 0.2, 0.4, so we just got a tiny little amount of voltage. So we're going to go back over to the alternating current side, and if I can get my thing to stand up, and we got our 55 volts, 55.5. So what I'm going to do is I'm going to take my antenna, take one side of it, I'm going to hook it up to this bridge rectifier here. This is a full wave bridge rectifier. It basically has 4 diodes inside of it to rectify or change the waveform of alternating current into direct current forward pulses into a usable form that you can use to charge capacitors. Now, okay, I got this hooked up. I got my current is flowing in. My alternating current from the atmosphere is flowing in. I have it going through my full wave bridge rectifier. The positive is the side that's got the little knob took off of it. Otherwise, it's usually marked. There's a positive and a negative on the outsides. The 2 insides are my antenna, my alternating current antenna coming in. And then I'll run one to my meter here, and let's see. It shows we're getting 21.8 volts of alternating current, but if we switch over to DC now, oops, overload. Okay, our DC current is 50 volts. So we're picking up 50 volts now of direct current straight from the atmosphere. And let's see, it's not traveling at a lot of current, but I can show you the current here. We got to take our positive and our negative off, and then I have a small little DC ammeter hooked up here. Let's go negative to that side, and now if you look really closely, I'm getting, sorry it's upside down, but if you can see that, we're getting 0.1 milliamps of current, which is not a lot. No, that's tiny, but 0.1 milliamps of free energy from the atmosphere rectified into a DC form, which we can use to charge capacitors now. And let's see, our voltage is coming in. Okay, anyway. Yeah, so we're still at 50 volts. We got 0.1 milliamps of current draw, and that is how I rectify Tesla's radiant energy into a DC form. Now if I want to, I can take, got this big boy over here, this big boy capacitor. Now I'll hook my positive side up. We'll test the capacitor. I need more alligator clips for this. Okay. Dang it. Oh. Okay. So the capacitor shows nothing. Capacitor is completely dead. I'm gonna hook up this battery clip, or hook up this Tesla's this radiant energy receiver. Sorry, I keep getting on with the words, whatever it's called. And now let's get our meters here. Come on guys, let's work together here. Okay. And now we are charging. We can watch this capacitor go up. Let's switch this over to a little bit. This is our DC capacitor. It's an electrolytic capacitor. It's a 400 volt capacitor, but what I'm using it now, I'm using it to charge this. I'm using my radiant energy receiving antenna, which is free atmospheric electricity. I'm rectifying it through a full wave bridge rectifier, and right now I'm up to 11 volts on my capacitor. And if you see, that's actually charging pretty fast. We're at 12 volts. I don't want to overload my capacitor here, so I'm going to stop it, but I'm actually going to take this off right now. Boom, and our capacitor is already overloaded. Our capacitor is sitting at 50 volts. Boom. So, oh no, wait, that's my, sorry, I took the capacitor off. Our capacitor is sitting at 15, we're sitting at 15 volts with the capacitor. If I take it off, that's our original, that's our 50 volts incoming at 0.1 milliamp. So at 0.1 milliamp, doesn't take long to charge this capacitor. As you can see here, I leave this on here a little bit longer, we're at 16 volts, 17 volts, 18 volts, there it is. We're charging super quick. So there it is, Tesla's radiant energy receiver.